Hi everyone and welcome back. Welcome to my another stream, and in this stream we are going to talk about really interesting topic. So till now we talk about how to build the APIs, how to do the front end, how to build the Next.js application, how to build the React app and all. But this is totally a standalone topic which is all about when to choose and what. So sometimes when you want to build a API platform, then you sometimes get confused. Okay, should I choose REST interface? Should I choose simple gRPC, simple GraphQL interface and all, right? So this is always a question, really a burning question, when to choose what. And we sometimes get confused. Okay, I want to build a API platform, what should I use? Okay, so we'll try to answer all these questions and we can answer all these questions only by understanding the use cases. And then we will talk about simply GraphQL interface and implementation, how we can do that using simple express, because sometimes people are not comfortable with the Nest.js. Mostly I use Nest.js for either API development or a GraphQL implementation. For all these use cases I always use these kind of scenarios. So REST interface, I think most of you are already aware what is the use case of creating a REST interface, why we need it. So earlier we used to have SOAP based web services. If you remember those days, I'm talking about, let's say, 7 years down the line, or 7 to 8 years, we were having SOAP based web services. And the server used to expose WSDL, which is a definition language, and we used to consume the WSDL and used to create a client. Okay, that is totally a different XML and a JSON based integration we are doing. Then it comes REST is representational state transfer, and REST APIs we are using since last maybe let's say 10 years, and it is still there and it will be there because lots of tools and technologies are built on top of REST provides us a unified interface which can exchange the content, either a text HTML or JSON object or a multi-part form data. Any kind of data format can be exchanged between client and server. Not in even in client and server, the communication can be between machine to machine, right? One machine is communicating to another machine. So this is like API interface we are talking about. So there can be services which are exposing these kind of a REST, GraphQL, tRPC, gRPC interface, and then there will be a communication between those different services, those different machines, through some interface, and that interface can be REST, GraphQL, tRPC, gRPC, or simple RPC interface. So you are exposing some kind of a unified interface from one particular service which can be consumed by another service. So this is how it really works. And then we have a GraphQL. GraphQL is built on top of REST only, and it has lots of advantages. Like, let's say when you have a traffic coming from the low bandwidth devices, then you can use GraphQL, because in the GraphQL you can decide what data you want from the server. It's still, you can consider that as a REST API, because here you are sending a request on the HTTP post and you are sending a query and mutation to the server. So it based on these two things, query and mutations on HTTP post. You are still using the same HTTP protocol, and you are sending HTTP post and sending the query. Okay, I need this data, and in the query the client can decide what data you need. You can just say, okay, I don't need that much data, I just need a small chunk of data, or I need a whole data. So client can decide, and all other advantage, like you can do the aggregation of the data at the server side and can decide what data needs to be sent. So for the low bandwidth devices, this is really optimal solution. And when it comes to data aggregations, GraphQL provides a nice integrations. You can aggregate the data and can send the data in a single query, where REST APIs you need to trigger a multiple API calls. Then there is a tRPC and gRPC. Let's talk about this with ChatGPT also. What is tRPC? I mean, this is a TypeScript unified interface. Let's see what it is. tRPC stands for this definition. It refers to family of channels. Okay, I will just try to tRPC server in Node.js. I don't want to use some repeated definitions. So what we are doing with the tRPC is exposing, it's like TypeScript RPC. So we already know how the RPC works, right? Remote procedure call, in which at remote server you define the methods, and client already knows, okay, what all methods already defined at the server side. So what we are doing is we are creating a tRPC server, and in the tRPC server you are actually initializing, you are defining all the methods, TypeScript methods in the tRPC, and it is using this tRPC TypeScript. Do it. You can use tRPC with the express simply. I mean, this is how we create it. We just create a router and we will pass the router with the express. So you might be thinking, okay, how to create a basic implementation of tRPC. I think this is very easy, and I will be doing a demos also on the T3 stack, tRPC, Prisma and all. But you just install tRPC and then create a router. So I'm just creating a simple router. When you are querying hello, I'm going to return you hello world. And then you can configure that with the express middleware. So whenever there is a tRPC route coming, I'm going to create this web server with this router and then start the express app by just doing app.listen and node server.ts. Now you need a tRPC client. So tRPC react. What happens is you have a tRPC server. Now you need to have a tRPC client in the React app, which can actually access this tRPC server interface. So here you need to create a tRPC client. Similarly, gRPC for the GraphQL also we create a GraphQL client at the client side. Similarly, we are just creating a create tRPC client, and this client we are passing as a provider in the tRPC client provider, and then all our child components will be rendered here. And then we can just use query, and use query, it is actually a hook provided by this tRPC React that will give you the data which has been received by calling a particular tRPC method, router method. So we are triggering a hello method and we are just printing it. That's it. Simple information, right? A simple gRPC. So if we talk about simple gRPC interface, gRPC is a high performance, and this is a way of communication between two systems on using proto buffers, right? So you remember in the RESTful APIs, what we do is we exchange the messages using JSON objects. Here there is a protocol buffers we define, and we generate a client and a server code. We can install the gRPC, and this is how we define the proto buffer. So this contains, okay, what this server is providing us. Okay, this is a service and these are the different methods which it is exposing. And what you do is you will just use this gRPC proto loaders and you will just create a simple service. We will not go into the code like how you are creating a simple express app, but this is simply creating a simple gRPC server. Right now, let's say talk about gRPC GraphQL with express. So we are talking about everything. Now we can also talk about simple express GraphQL application. So we require express, and it is going to use express GraphQL. You can also use Apollo GraphQL or Yoga GraphQL. And here you are just going to create a schema which contains the query and mutation. Okay, query and mutation, and then you just expose an endpoint. And you will just provide a schema that contains the queries and mutation. That's it. So it's just an example I was showing you through this ChatGPT. Okay, this is how the GraphQL works. Now, what we are going to do, we know, okay, how REST works, how GraphQL works, and how all these other platform works. So we have a REST interface, GraphQL interface, gRPC, tRPC. At least these four interfaces, you should be aware how they really works and how to work with them. So while implementing a backend system, your backend system, mostly what we do is we end up creating just a simple REST APIs and just do Axios get put post from your client. But you can expose your API interface through the gRPC. Then you will be creating you can just use a simple GraphQL. Then you will use a GraphQL client. You can use a tRPC with the express. Then you will be using a tRPC client React to access the tRPC methods which are exposed by that. Okay. So what we are going to do is, first of all, we are going to explore the GraphQL interface, how the GraphQL really works, and how we can use GraphQL using Yoga GraphQL, or you can use a GraphQL with the Nest.js GraphQL, or Apollo GraphQL with Express or GraphQL Express. So there are many libraries. So let's say if I talk about simple GraphQL. So what all you can use Apollo GraphQL, you can use Express GraphQL, you can use Nest.js GraphQL, you can use Yoga GraphQL. Okay, and all these tools can be plugged in with a different database and all. Apollo GraphQL, you can just integrate that with the Express, and there can be ORM tool associated with that like Express, Prisma and all. Express GraphQL, similarly, it's already using Express. Express GraphQL is actually library which and then you can attach some ORM. Similarly, the Nest.js GraphQL, it provides a two different approach, schema first and the code first approach. Here you can use a type ORM or Prisma, whatever the ORM you wanted to use. Yoga GraphQL, this is like a simple library which you can plug in with the Express app and you can attach some ORM. So there are many ways you can build a simple GraphQL service, either using Nest.js or simple Express, or by using, so Express is a framework and Nest.js is a framework which will use these providers, either Apollo provider or a Yoga GraphQL. Okay, so this is the variation. When you don't get confused, the Express and Nest.js is a framework. They will use either a Yoga GraphQL or Apollo. I mean, Nest.js use Apollo GraphQL and they will allow you to build your GraphQL interface. Okay, so let's talk about it. Hi everyone and welcome back. Welcome to my YouTube channel. And since last 2-3 weeks I was not posting any latest video, but now I come up with the latest playlist on the channel. And since last 2-3 weeks I was not posting any latest video, but now I come up with the latest playlist on the GraphQL, playlist on all different kind of ORMs in the Node.js, and we'll also talk about Kubernetes, the Neo4j, and everything from the latest technical stack. Okay, so this playlist will primarily talk about the GraphQL things. So if you talk about the GraphQL ecosystem, that is totally exploding these days. We have a lot of new libraries are coming and a lot of new frameworks are coming that is supporting the GraphQL client, GraphQL server, all these things. So if you talk about simple GraphQL, you can create a simple GraphQL server on top of Express. You can use Apollo, you can use Yoga, you can use different kind of libraries to build a simple GraphQL server. So we are going to talk about all those things. So this playlist is primarily going to talk about all these different libraries. We have GQL, type GraphQL, we have GraphQL iOS, FastQL, Nano GraphQL, Prisma, which is kind of the latest technology, and it is known as a lightweight ORM for the Node.js connecting to all different database. And there is a Yoga, which is a GraphQL, which is a library helping us to create a GraphQL server, URQL, Neo4j GraphQL, which is supporting the integration with the Neo4j and expose the data in the GraphQL queries and the mutation. Apollo is already a popular stack. We are using Apollo client, Apollo server. We are using Apollo server to create a GraphQL server, right? So GraphQL libraries are like, a lot of libraries are there. If we talk about this GraphQL, GraphQL Hub, they have their own set of libraries they are using. Apollo stack has its own thing, Apollo client, Apollo server. Prisma is coming with a simple ORM, but it has a nice integration with the GraphQL servers. Okay, you are writing GraphQL server, talk to the Prisma. Prisma will take care of getting the data from the all different database. And also Prisma is providing a nice and clean database client that is totally different in the Node.js world. So we are going to use all these different libraries like type GraphQL library with a simple TypeScript. We have these Neo4j GraphQL talking to the Neo4j for the GraphQL queries. Yoga is a library which is helping us to build a GraphQL server. And there are some app sync, Apollo client for the AWS and all these things. So this library, this playlist is primarily going to talk about the GraphQL libraries, GraphQL ecosystem, GraphQL client, GraphQL server, what all different libraries you can use to build your GraphQL application. Like we are going to use a Yoga and Apollo stack, and then we are going to take a look onto this GraphQL Hub, and whole lot of this GraphQL ecosystem. So it's going to be massive because we are going to talk to different ORMs with the help of Prisma. I mean, Prisma will talk to the different database, and we can also use different Node.js ORMs. Like we are writing a GraphQL server in the Apollo, and then I need to get the data from the database using SQLize, using type ORM, using Next, or using ORM2. These different ORM libraries will help us to get the data from database, and GraphQL queries and mutation will help us to expose the data through the GraphQL client. We'll talk about GraphQL authorization, GraphQL pagination in the GraphQL, how to do the aggregation of data using writing the different schema definitions, queries and mutations and subscriptions. So it's going to be very big, and it's totally new. I mean, I don't have a playlist talking all these things together, so it's going to be massive for my subscribers. Okay, stay tuned, guys. Thanks everyone. Hi everyone, and welcome back. Welcome to my GraphQL in the context of Node.js, and with the different providers. Like we are going to talk about the Prisma, Apollo, Yoga, and all these different GraphQL clients and server. Okay, so what is the primary agenda of this particular playlist? We are going to talk about Apollo, Prisma, Yoga, and different GraphQL frameworks which are available in JavaScript world. Okay, so our primary focus will be on these different sections. Okay, if we talk about what all we are going to talk about is, first we will try to understand the GraphQL. I already have created few playlists. If you want to have a look how GraphQL works, I have covered GraphQL with Apollo, GraphQL with the basic Express application. Like there is Express GraphQL, or if you want to implement it with the Apollo, then there is Apollo GraphQL server, or there is a Yoga is another library using which also you can create a GraphQL server. So there are many ways. So first of all, we will try to understand GraphQL schema, queries, mutations, subscriptions without any kind of database. Like with a simple JSON we are going to play with. Then we will understand how to write a query, mutation, and subscription. That will give us the simple insights about the types, schema definitions, and all. Once that is done, we are going to have an integration with the database. Like mutations and query. Query will fetch the data from the database. Mutations will mutate the data, mutate the database state, like update, delete, insert, all these things. Then it's all about all different libraries we are going to cover, which is like Neo4j GraphQL, RQL, GQL. We have Apollo server, Apollo GraphQL server, GraphQL. Type GraphQL is another library which is heavily on the TypeScript side of writing a GraphQL server in TypeScript. Then there is a Yoga, which is another library to create a GraphQL server, where you are just providing the schema files and just creating these mutations and queries. Okay, so we'll talk about GraphQL authorization, GraphQL API pagination, how GraphQL can connect with the Prisma, and Prisma is like a ORM layer, can do the insert, update, delete in the database. So your database entities can be as simple as a simple CRUD operation, or as complex as simple shopping cart application we can build. We have the product, we have the cart, we have the user. These kind of relationship we can maintain, and we can choose one of the ORM, type ORM, SQLize, Prisma, or Next as a query builder. If we don't want to use a heavy ORM, we can use Next. So all these things I'm going to cover in the playlist. So I'm already covering another playlist which is talking about ORM, or entity object relational mapping, right? And there are multiple libraries: SQLize, type ORM, and Next, ORM2, and another is a Prisma, right? So if you are going through that playlist, that will also help you, and through this playlist you will also understand how to expose the data through the GraphQL queries and mutation, because that ORM playlist is talking about how to fetch the data from different database using different ORM, and that is purely REST. The only difference is here we are going to talk about GraphQL. So only the difference is there I will be talking about REST, here I will be talking about GraphQL. So GraphQL, here we will be mainly focused on the query, mutation, and subscription, how to actually hit it from the postman, how to expose the query and mutation. There we are going to talk about the basic REST APIs, which is going to do the complex calculation of the data with the help of the type ORM. or maybe with the simple MySQL Postgres query you are going to hit to the database. Okay, so this is my main focus for these two different playlists. One is talking about the ORMs in the data in the Node.js, because people are familiar with the different ORM, they have a different perception, so we will also do a relative comparison where to go. Okay, I just wanted to write a simple CRUD. Why you need a ORM? You can write a simple SQL queries. Okay, but when you wanted to manage the migration seeders, let's use ORM for that, but rest you can write a SQL query, or you can use this Next as a query builder if you don't wanted to write a plain SQL queries. Okay, because this is lightweight, this is not creating wrapper classes. Like Next is a query builder, simple query builder, but you want a type ORM for the relationship management, one-to-one, one-to-many, many-to-many. You don't want it to write any query builder thing and all, then you can use type ORM. Still you have to use some utility methods to do the join, to do the select and all these queries with the help of type ORM also, because type ORM is just a custom wrapper. But when you need to write the complex queries, complex join, one-to-one, one-to-many, many-to-many, you still have to figure out how to fetch the data from multiple tables. Similarly, SQLize is a popular one, type ORM is popular with the TypeScript, Prisma is something which is totally new, Next is very popular for the query builder. Okay, and so there is a lot of things going on with the GraphQL and REST API. So my both playlist will give you a lot of insights, and I will be providing the GitHub link where I will be talking about, okay, this is a project, GraphQL with the Yoga, with the Postgres, GraphQL Yoga, or maybe Apollo server with the MySQL and type ORM. Okay, there may be a number of permutation combinations. Okay, let's get started. Thanks everyone. Hi everyone and welcome back. And here we are going to start our GraphQL series. And first we are going to talk about the Yoga, a GraphQL library to create a GraphQL APIs. Okay, so we are going to start with very basics, then intermediate, then advanced, and we will talk about GraphQL with the Prisma, GraphQL with the SQLize, type ORM, GraphQL with the pagination, authentication, authorization, and the testing the GraphQL APIs, right? So all these things we are going to cover in the whole series. So first we are going to start with the very beginner. Okay, and we will start this with the setting up with our basic project, right? And what we are going to use, GraphQL Yoga as a library. You can also use Apollo GraphQL, and we are going to use ES6 Node.js, like we are going to use the import syntax. So we need Babel. So what we did is in the package.json, we just added these two dev dependencies, Babel CLI and Babel preset env. That's it, and the GraphQL Yoga. These three libraries, nothing else. And how to create a basic GraphQL server with the Yoga library. I'm not going to cover very basic like what is GraphQL and all these things. I have already covered a lot of playlists talking about GraphQL, REST, what is good, when should we use what. There is nothing bad and nothing good. It's just about the use case. On some places the REST is always better. On some particular use case the GraphQL is better. Okay, so here if you just see, I just have an index.js file in the whole project. And what this index.js file is talking about, simple bare-bone GraphQL server. So what I did is I imported GraphQL Yoga, I got the GraphQL server, and I'm feeding only two things in the GraphQL server. One is a type definition and another is a resolver. So whenever we talk about GraphQL, we are going to talk about these two terms a lot. GraphQL server, type definitions, resolvers, query, mutation, subscription, and simple GraphQL server, right? So if you see, the type definitions are nothing but you can relate it with the TypeScript types, right? Where we are defining the types, enums, interface, classes and all. But little bit different here. These schema means we are creating the types which you are going to expose through the query and mutation. These are the resolvers. Resolver is an object where you will define the actual implementation for your query and mutation. When I say, so GraphQL can be divided into three things: query API is where you are requesting a data. Mutation API is where you are updating the state of a data. Subscription API is where you are listening to a change happening to a particular data set, right? So these three things GraphQL exposes. In this hello world example, I'm just exposing a simple query. Here you can write mutation, subscription in the type definitions, and the actual implementation will be defined inside a resolvers. That's it. Now you just pass both the objects into the GraphQL server and it will start. This same implementation you can do with the GraphQL Express server or using Apollo GraphQL server. Here we are using GraphQL Yoga. There are many libraries are available right now which does the same thing. That will help you to create your GraphQL server. Directly or indirectly they will ask you, okay, what is your type definition, what are the resolvers you wanted to expose, and what we do is we can just do npm run start based on package.json definition, npm run start, and it should be able to start our server on a defined port. Okay, once this server is started, we can do a lot of things. Here currently this is doing nothing. It is having one simple plain query which is hello. So this query will be exposed when you try to see this GraphQL like REST. In the REST we look for the Swagger APIs. Okay, what is a get, put, post, delete API. Similarly, in the GraphQL it also provides you the GraphQL browser console. Okay, we can use different add-ons which are available on the browser. So you just pass this and you can access all the query and mutations available. We have only hello query here. Okay, stay tuned. So this is a very basic setup. You can actually copy this from the GitHub. Simple 3 libraries. GraphQL Yoga is a library to create a GraphQL server. I'm using this Babel CLI and Babel R. This file is required because this is what will tell GraphQL to define the presets. Okay, how to compile, what to compile. Okay, so let's see in the next video. We'll expose it on the browser using some add-on. We will see what kind of documentation we are getting, same as Swagger. So GraphQL is nothing but an API interface, little bit different than the rest, because in the rest you have a different HTTP verbs, get, put, post, delete. Here we will talk only about post, and we will be send a query and mutation and subscription through that post API to our GraphQL server, and we will receive the data in the same way we were receiving in the REST APIs. Okay, let's talk that in the next video. Hi everyone and welcome back. So this is the simple example we have done in the last video, and I'm using one add-on on the Chrome browser that will give you everything you need. You send a request. This is your simple documentation. Okay, I have only single query, hello, and you can do a click here. This will add that query for you. You don't need to even type anything, and here you can just enter your name and then send this request. Okay, so it is just adding hello and giving you the message back. So this is like a query we have written. So, and this documentation is like a Swagger here. It is telling you what all queries you have, what all mutations, subscription, what all different types you need to define. Okay, everything is here, and you just need to you can execute the queries here. Okay, now what we are going to do is let's move to a bit advanced. Okay, here we are creating only a simple GraphQL server, right? But we are not going to write this simple hello world example every time. What we will do is we will start defining these type definitions. Type definitions means, okay, let's say I have written the CRUD operation of user, CRUD operation for post. So there I have a get, put, post, delete operations, but here I don't have all these things, right? So how can I replicate the same kind of scenarios here through the query and mutation? Mutation will create user, create post, update user, update post, delete user. All these things we can also be able to do with the help of GraphQL. So first of all, this is the type definition. Okay, and in this type definitions we are going to put all the things which we need, right? So this is the type query. Before that we will define all the types which we need. Okay, like I have a type user, and inside type user I have few things. Okay, I have ID, I have name. All these parameters you can add. Name is of type string, Okay, then I have an email which is also of type string, and then age, let's say this is of type int. Okay, so I have created this as a type. You can call it as a model, which we are going to expose maybe through query and mutation. Okay, then let's say there is another is a type, which is type is post. I will not cover more these basic things because these are, we already know what all these about. So in the post we have a title which is of type string, body which is of type string, and we have published and which is of type boolean. Okay, now there is a meaning of these types: id, string, boolean, object, all these are actually types. So this is a parent type, and these are the types of each and every property that we are defining inside a post and user. Now query, inside query I can have, okay, let's say get me. This can be one query, and what it is doing is it is just returning what this query is going to return. This query is going to return user type. Okay, then another query I have is post, that is going to return the type post. Okay, so this is my type definitions. Now when I look at the resolvers, I need to define the resolvers for the query and mutation. Here currently I have only query, but here you can define mutations also, and then we need to take care of query and mutation both inside resolvers. For now we have these query, and query is talking about, okay, there are two queries, this should match. Okay, I have a get me and post. So let's say get me, which is a function inside a query. What it is doing, let's return something here. So inside a query object we have a get me, and get me is just returning a simple object, and the object has the same things. We have id of type string, and we have name, and we have email. Okay, whatever the email, right? So we have name, email, everything here. So this is my first query here, get me, and then another query I have is a post. So put a comma here. This is my another query post, and this is going to return the data regarding the post. Here in the post we have all these types: id, title, body. Okay, id, title, body, and we have published flag, which is, let's say, false. Okay, what I did is I created a type definitions, and I define these queries get me and posts here. Okay, now we can restart the server, or we can add a watcher which will keep restarting this. So we have post and we have get me. We just need to take care id, name, email. id, name, email, these are required things. Age is optional. In the post all are required, so we have to define all. I mean, you will get an error if you are not returning the required type from there. Okay, now we have extended this example. Now we have multiple types. Let's say, let's reload this. Now we got these two queries, right? Add this to the query, get me, you can run this. Okay, I got the data, right? And another query I have is post, and this is another query I have, and it is giving me the post data, right? The representation is still a JSON object. Inside it I have a post object that is giving me everything. And you can see whenever you are running a query, what we are passing, we are passing the post, because post is not taking any argument. If you talk about simple get me, right, that get me is not taking any argument, and it is of type query, so we wrapped it inside a query and then get me, right? There will be a cases where we have to pass the user ID and you have to return the data of selected user. Then the query will be here, you will be passing the argument, but currently it's not matching because this is not according to the spec, and you just send it, we will get the data accordingly. Okay, here we are requesting age, but that's null, but now we are requesting only ID, name, email. Okay, so this is how we define the type definitions and the resolvers, and once the server is started, we can test that through our this GraphQL console. Okay, thanks everyone. Now in the next further videos, we will talk more about the queries, mutations, these types and resolvers, because that is all about basics, and we are not going to have an integration with the database. Let's say we have the collection of users. You create a new user, we will push that into an array, you delete, update, all these. We are going to play with just a collection of array objects. Okay, and then we will write these queries and mutations. Hi everyone and welcome back. So we are talking about basic GraphQL APIs, basic queries, and now we are going to extend this example with some mock data like mock user, mock post, mock comments data, and we will try to define the types accordingly. Okay, before that I have done a small change. I have added a node mode and I have added node mode exec, that's so that we can run this in the watch mode npm run start. I mean using node mode, whenever you do the file changes, it will restart our server. Okay, coming to our index.js. Before this, what we will do is, let's say we are defining some entities, user, post and comment. These are the three entities we are targeting, and based on that we are going to define the queries. Okay, so we are going to generate some mock data, and here we have queries. We are going to have more queries when we are introducing few more models like user, post, comments. Okay, so this is the type user, type post, and let's say we have one more which is comments. Okay, and here we can just say, okay, whenever you are sending a comment, I will send you the comment type. Currently we are talking about object, but this can be simply an array also. Okay, and what this exclamation means, first of all this user is required, and then the array is required, means you inside array user object needs to be there, and then array needs to be there. Okay, similarly we have comments, and this is also required. So let's say these are our queries. We can call it as a posts. This is simply me, this is comments, and okay, these are our queries. Now when we are defining the resolvers, what we will do is we will just generally dump the data in form of an array, which is user, post and comment. So comment can have a message and body, that's it. Okay, and we can define our queries, which is, let's say it will become me, and me is returning, it should always return an object, not an array. So we are good here. Posts and comments, these are the two other queries we have. So we are good with me, and we have posts, and we have another is comments. And we always need to remember that we are going to return an array, not an object. And here it should be title, should be message, and body. This is comments, id message body, id message body, id title body published. So now this is our simple server we have written. Okay, we did a frequent change, so Babel node is restarting. Now there is some error. If there is a mismatch in the type definitions, then there will be an error. I think it's already, what we can do is npm run start, or in the node mode you can do a delay so it doesn't frequently restart. Okay, now we have this type query, we have user, we have post, and we have comments, and based on that we have defined the resolvers. You can see what all queries we have: me, posts, and this should be comments. Okay, so our resolvers, this should particularly map with our query. This is comments. Okay, in the resolver we also have comments. Here we have posts, and me, here we have me. Okay, now for now we are just fetching the very basic data. If we just go with our Swagger, I'm in GraphQL console, we just reload, we'll get the documentation, and here we can see all the queries. Let's say I want to do a query for comments, and whatever data we have, because we are hard coding right now, and why it is complaining, cannot query fill text on type comment. Okay, let's see this. Or let me maybe reload this, so we can get the updated type definitions. And here we are doing add query. Yes, now this is the correct format which we have put. Now you can actually execute a multiple queries also. This will give you the data. I mean, this should be defined inside and in a single query. For now, let me just give it a try. This is comments, this is posts, and this works, right? You can actually nest it inside a single query tree. Now we have the me object also. We can put that inside the same tree, because there should be one root query or one root mutation, and we are getting all the data, right? Now we are just throwing some dummy data, hard-coded data, but this is not what we want to achieve. What we want to achieve is, when you are saying, okay, give me this user, I should also be able to return the comments, the posts. When I say the post, give me this particular post, I should also be able to return the author of the post and comments on that post. When I say give me the list of comments, then I should be able to return the username, the author name who has returned that particular comment. Then only we can have some real picture about how we are writing GraphQL aggregations, right? Currently it's just a mock data JSON response on the comments, on the posts, and on this query we are returning it. So based on that we will also define our type definitions. Like, let's say currently we are passing these, but now we can change our query definitions. We can say, okay, we have users, and here you can pass the query as an input, which is of type string, and we can do the filter, and then I'm going to return all the users matching with this particular criteria, and this is required. Same thing I can do for the posts and the comments. So here I have posts, here I have comments. Comments, I don't need to do a filter, I will just return all the comments provided by all different user. Okay, let's clean this for now. This is returning users, this is returning the post, array of post, array of users, array of comments, right? Now we will define our user type. So now we have to mix and match all these types. We can't just say, okay, from the users query we are just returning only these parameters. We can also return the posts, the comments, right, from this user definition. So what I will do is, okay, the posts returned by the user, okay, here I can also return the comments written by the user, right? So I can return the post type and comment type from the user type. This is how we will be mixing these types, because if I'm requesting your user, I can also request, okay, give me the post, give me the comments returned by this particular user. And similarly for the post, I can return the author. I can add the author here, and I can add the author for the comment. Now the only thing is we need to handle these separately in the resolvers, right? Because what we are handling is, okay, in the users we are returning the user type, but now in the user type there are posts and comments also there, which we are not returning from these resolvers. If I just change this to the users, and now the users and posts, they are taking string as an input, right? So all those things we need to handle. So let's connect in the next video and we will fix this. We will pass the string in the users and the post, and we will return the required data, which says, okay, the basic user information, and you can also request the posts and comments array. Hi everyone and welcome back. Let's complete this example which we started in the previous video. So here we have these three queries: user, post and comments. Okay, and these are the type definitions for user, post and comments. Okay, now the only difference here is now we have started taking the argument as an input, query as a string, right? That means you can pass the username, the post title, and then you can ask for the list of post matching with this title, ask for the list of user matching with the particular ID or name. Okay, so the question here is, how can we accept the argument, right? So we'll talk about it. I mean, how in the query and mutation you can pass the argument. Here, every resolver function, either query or mutation function, takes all these arguments, context, and info. Okay, we are going to use this argument object to check if from the query we are passing the query or not. Okay, so here we can just do a simple check. If from the arguments, if we are getting query, if we are not getting query, that means we can just return the users. And now we can also create the mock set of users that will just list of users. So we can create some user list. Either let's create another file here, mock.js. Okay, here we have a list of users and the list of posts, because this is what we are going to return. And we also have a comments, so we can return the comments also. And the data structure is same, and we can simply, I think, export const, and we can import it there, export const user. Right now we can import this mock data, the users, posts and contacts, import everything from our file which is mock. Now what we are getting from here is list of users, posts and comments. Okay, we are good. And in the query, if you are not passing the username, what we are doing is we are returning the list of users. And similarly in the posts, first of all we'll define the arguments here, same as the users, same for the comments, and here also it's comments. I think we can return the list of comments. It's it. So I think now our most of the errors should resolve, because now we are returning the expected types. Okay, let's see what is the error here. Did you mean string? Okay, unknown type, somewhere we have return string small. Is it? I don't see. I think it is talking about this. And this is required. I mean, this is optional. If it is required, then you have to put exclamation saying that this argument is required for the query. And now we can see this is our type definition, this is our resolvers, and our server had started, right? Now if we go to our documents, reload and documents, these are our new set of queries, and here we can pass the name. Let's say what kind of user data we have in the mock. We don't need to worry about passing the argument because we are not handling that right now. We are just saying if argument is empty, if we are not passing any argument. Let's say if I remove this, then that can work. But now this is complaining. Let's say this is the query and it is working fine. Similarly, you can do the posts, like I can add the posts and I will not pass the query parameter. So this is user, this is posts, and I can just submit this query. Cannot return null. Okay, let's see what it is. Users and the posts dot title. Okay, let's see we have title or not in the type definitions. ID title body. Okay, in the mock data, ID title, yes, we do have that information. ID title body. Let's see why this is complaining. Return null for non-nullable fields post dot title. Let's see if I'm just hitting this only. Posts dot title. I mean, this is because the title is required field and we are trying to return an empty value. So if I make it optional, then it will start working. But why it is complaining? Let's have a look. Okay, yes, this is the problem. I should return posts here, not users, because I did copy paste that caused that problem. Now everything should be fine. You should be able to get the posts and comment. That's it, right? But after this, how can I get the nested data? Okay, the user, how can I get the post and comment of a user inside a single request? Now I think this should start working as expected. But if you remember the type post, right? Post is returning this type post and it is having all these attributes. If you see this, it is going to return this post array, and inside post we also have author information. So how can I get the author information? If I just put author here, I can talk about ID. But where this information is going to come from? Author.id. We don't have in the posts, we just only have the post array, right? Which has ID, title, body, published. But how can I capture the author information in the same aggregation, right? In the same request. So here comes our additional types, right? We have till now we have created a simple type, simple queries, users, posts, and comments. But here we can declare the types, okay? Because in the comment, how can you resolve the author information? Because this is a nested type, because it is pointing to another type definition. In the posts, I'm getting ID, title, body, published, but I don't have information about author. So can you tell me how should I resolve the author information? Similarly, in the user, there is a posts and comments. How should I resolve both the posts and comments? I don't have information in the resolvers. So we are going to add that information here. What we are going to do is let's say comment.author, right? So if I want to populate the author information of that comment, then there should be some common attribute I should look for. Let's go to the mock data. Here we have the posts. If I wanted to get the author, there is an author ID, and from the author I can fetch this information, right? Similarly, there is a comment and there is a author information, author ID 3. Okay, I can fetch this information here. So we can resolve this data through the resolvers. Okay, when I'm saying is in the comments there is author property which is resolving to the user, but I don't have it. So how can I resolve it? I need to define those types here in the resolvers parallel to the query. So all the queries will be resolved here. But let's say if there is a custom type, how can I resolve post? You can see inside a post type, I think we have author. So how should I resolve author information, right? So for that, inside the posts we have author, and author information, how the author information is related to the parent object. Let's check that out. Here also it is going to, we can pass the same set of argument, and here we are going to use the parent object to get the selected user ID. Okay, and we can simply do, this is important, we can simply do return users.find, and I can just say give me that user where user ID is same as parent.author. Okay, yeah, so let's go to the post. This is our post array, and here we are talking about author, right? So inside a post we might be looking for the post ID, right, and this author. So what is common there? We are checking for this particular property parent.author, means we are looking for that user whose ID is same as the ID of the parent.author, which is available here. So the author property in the post type is resolved. Similarly, we can resolve the other types, which let's say the comment. Inside comment type we have author property, so it can be resolved in the same way. Comment context users.find and parent.author. Similarly, we have one more use case which is about the user. Here we have a user. In the user type we have, I think, post and comment both. So how should we resolve these both the properties, posts and comments? So this is posts and another one is comments. There are two properties I need to resolve. Okay, so I'm looking for a particular user information, like let's say you got a user object, right, that has a user ID. So for the user object, what I can do is wherever the author, so I can use this parent ID, where parent.id is same as post.author, because here we are looking for the posts, right? So posts.find, and here also comments.filter. We can do simply filter because we are going to return an array. We are going to return all the posts of that user and the comments. So we can say, okay, give me all the data where post.author is same as the parent.id and comment.author is same as the parent ID, I mean parent user ID. This is the user ID. So give me all the comments where the author is the same user which this parent ID is pointing to. Give me all the posts where the parent ID is pointing to the same author. That's it. And now we can see that in the demo. You should be able to see the nested data, like user with the posts, user with the comments, comments with the author, post with the author. Okay, so let's see that in the next video. Thanks everyone. Hi everyone and welcome back. So now we can just see the demo of whatever we have done in the previous video. Okay, so these are the queries we have written. I will just do a quick recap: users, posts and comments. Okay, And additional resolvers we have written for the post, comments, and the users, because whenever you are getting the users, right, you can also get the comments and the posts written by the user. So we can just do this, let's say this particular one here. In the posts we are also getting the author ID. We can also get the name, we can also get the age, right? All these arguments we can pass and everything is coming. So this is nice, right? With the post information we are also getting the user information, like the author information. And currently we are not dealing with the database, it's just a random data, had some matching IDs, like post has the author IDs which is same as the user ID, comment has the author ID which is same as the user ID. Now let's go to the documentation, we will try another query. Let's see the list of users, and this is important because we can do a lot of things with the user. Add query, we are not passing any query for now, and we can get the posts and we can get the comments. In the comments we can get the what all information is there, title, okay, ID is there. In the posts we can get the ID, we have what other parameter we have, title, and we can hit this and we are getting the exact information, the user and the posts written by the user and the comments same with another user, right? So this is how we are actually able to aggregate the data. Okay, user data aggregation with the posts and comments, author information with the comments and the users, right? So what we have done is, it's a simple example and this is how it is working. I hope this is properly visible on my screen. Till now we are writing only queries. Now we will make a small change because we are accepting this query argument, right? So let's say, what if user is passing some query, then we have to do the filter, and I can just do this const search user, let's say. And how we are getting this, we are getting search user from argument dot query, argument dot query dot argument dot query dot title. I mean argument dot query is the query is enough, I think, and we can just do two lowercase, so we can do a original compare. Okay, and we can do return users dot filter, let's say, because we want to return only those users which are matching with the search user keyword. Okay, and we can just do an includes operation. Here we can return, okay, this is filter, so we can return user. Let's put this user instead of I for more readability. User dot name dot to lower string dot to lowercase. If this includes the another search user, that means we have to return this filter user, right? Same kind of scenario we can put for the posts. If this query is not there, then return all the posts, but if query you are passing some search key, some title or something, here we can talk about the title instead of here posts. This is also users. We are doing some typos here. This is users, this is user, and this is, we are doing the filter on the posts list. This is a single post, and we are doing filter based on the title, and we are just comparing it with the search post. If it is there, then return all the posts which are matching with this criteria. Okay, this is plain and simple now, and this should work. Okay, now you can also pass the argument while fetching the list of users, fetching the list of posts, and based on that you can do the filter. Here we are just doing array.filter based on the title and based on the name criteria. Okay, so this is simple with the posts and comments, and it should just improve our results now. This is the documentation. Let's clear this out. Now we can add the query. Let me just run this. If we are getting the data, okay, we are getting the data. That is good. We can get the ID, and we can also get the ID. Okay, that's it. It's plain and simple. Here we are passing the query. Same way we can actually execute the posts query, right? So this is how you can pass the argument, and we can get this passed argument using the argument object, which we are passing here, argument.query. It will give us whatever you are passing there, and based on that we can do the filter. We can like you are returning the list of users. Here you can pass the ID, then you can do argument.id. It's same as we use express, and there we pass the query parameter, route parameter, or data inside a body. All these things here we are going to get from the argument object. In the express we were getting it from the request.body, request.params, request.query, different ways. Here everything is the argument object, whatever you are passing. Okay, this is GraphQL, that was REST APIs. Okay, so this is all about this demo. Now in the next video we will extend this a little bit. Hi everyone and welcome back. So in the previous video we were able to write our queries, and we were able to fetch the data like post and comments with the user, and author information with the post, and author information with the comment. Now this looks like we put everything inside a single file, right? Now let's give a particular structure to our project, and we can follow that structure later. So let's create one resolvers here, resolvers folder, where we are going to keep our all the resolvers. And instead of keeping this is a mock.js, we can rename it to db.js, because for now this is our database. Okay, and then we can have one index.js, which is like the main file inside source. Okay, let's import it. Inside source we have resolvers, db.js, index.js. Okay, and we can also move out this particular schema. Okay, so what we can do is we can create one file inside source. Let's say new file, schema .graphql. I mean, we are introducing new file extension, and we also need to compile it, but we will take the help of Babel to do this. And let's move our type definitions. Whatever we can see inside type we can put here. So the advantage of this is you don't need to worry about these backticks and inside type definitions, and we will pass it separately. So this is our type definition file. Here we have type query, user, post, comments. Okay, now we will also talk about our resolvers, and we will move all those resolvers into these files. Let's say this is a folder, so let's say create a new resolver. First of all, let's say query.js, which will take care of execution of all the queries. If we have any mutation.js, and we have other types like comments, posts, user. We'll create all the different files because we are writing the resolver functions for them. User, another is a post, and what other files we have? User, post, comment. I think that's all we have. Now start moving things here. So if we talk about the comment, right, So we can go to index.js, and this is the simple definition we have, and we can export this into our comment.js. Inside resolver we can create comment. I mean, things are going a little slow because we are doing restructuring, so bear me with that. On that, const comment, this can be a simple function. Okay, there is a typo, and here this is a simple function we have written. Comment has author information, right? And we can export this, export default comment. Okay, similarly we can put something for the posts. Okay, so for the post, the definition will be, if you go to our index.js, we have author and comments. For post thing, yes, we have author information. Now things will, we will start removing things from the index.js. This is comments. Similarly we have posts. Okay, here we can also have a comment. There is one more, comments, which comments is doing nothing but it is returning a comment for a particular post, right? It is also taking a look on to the same data. Or now it is context, and we will talk about how we can get this data source. So here currently we have comments which we are going to get from the DB. We will import the DB here, like const give me users comma comments equal to require, and this is our initial approach, but this is not going to be the final approach. To do it like this, we are going to use the GraphQL way of doing things. This is the post, and then we have a user. Okay, so user also will have the same thing. Here we will put the user here instead of DB. We are going to use users for now. I will explain what this DB is just in the next example. Here we have a context, right? So we have set up everything. Export default user, and now in the queries we will define all the queries. We don't have a mutation yet, so our queries, how these look like, if you go to our query, we can just use const query, and we can define all our functions from index.js, and we will remove it. So you can see these all are our queries. Copy and paste. And for now these resolvers we don't need, so let's clean them out. Type definitions and resolver. Let's go to our query, and here we can paste all these. So these functions are still the same. These are the queries, right? User, post, comments and all. Now we put like queries, different types, resolvers, and this schema.graphql file separately. How we can group all these things together, that we will do inside index.js. Okay, currently what all things are left here? Simple server. So we are going to import everything here from the resolvers, from the mutations and all. So let's say import query from, we have written the resolvers. Inside this we have a query. We will import it from there, and here once we have a query, we can create a server. Server is already there. What we need to pass is type definitions and resolvers, right? So let's put it in a little bit details. So here we need two things: type definition, which can be a GraphQL schema file. Okay, so you need to pass the path for this inside this particular folder. We have Okay, we have directly this particular file. This is there, and then we have a resolvers. This is another argument. Inside resolvers, it can be simple object where you define all your resolvers. Okay, we'll talk about all the other arguments in the GraphQL server. We have the type definition, resolvers, and you can also pass context. For now, let's pass this as an empty object, and then we will discuss about it, what all things we can pass inside context. Okay, so inside source, we have everything. So these are the resolvers, db index.js schema, and inside index.js our type definitions should be coming from root path, otherwise we may get error. So it is inside source schema GraphQL resolvers. Okay, resolvers, you can put query. If you have written mutation, you can put that. Otherwise we have like this user, post, and comment, and we are going to import all these things. User, comment, post, right? I can just copy these from my example. We don't need this db instance here. Okay, we can pass user, post, comment, right? The same thing, same example. Now we just distribute things into different files, different folders. Like schema will have its own folder, so we can define all our schemas. Now this can be as long as we want, like all different types. We can define type comment, post, user, query, and now we can also think about some mutations, right? Till now we were talking about all the queries, but we can also define mutation, and then inside resolver we have to define the mutation.js and have to define the implementation of all these mutations. So this is mutation. Let's say our first mutation is a create user. Okay, create user will take some input. Now we can also create a custom input here. Let's say create user input. This is a custom input because here the input payload will be an object, not just a string. Right, so create user, then similarly we have a delete user. I will talk about these two examples first. And this is id. So how we will access it? Using arguments.id, arguments.data, and this id is of type id, and it is going to return a user. Right, similarly we have update user. There can be another type, so what we need to pass here is id. This is the first argument, and data is another, which can be of another type, update user input. Now let's quickly, and these are required, right? Because in create, this is the required input, and once the create, update, and delete is done, we are returning the user object. So we have to create this create user input. This is the new type we have defined. So this is the input type, create user input, and it is going to have a name of type string, which is required, email of type string, that is also required, and then we have is of type int, which is optional. So new type we have defined create user input. Similarly update user input, update user input. I hope this is clear what we are doing here. Inside update, I mean, this is not a JavaScript, we are writing inside a .graphql, so automatically things will not appear. So this is create, then inside update we might be asking only a few small things like, okay, a partial payload, because we are already passing data, and all these things are optional because it's update, right? We are not creating, we are just saying, okay, if you want to pass, we will use these attributes to update. Let me see if I can format this. Oh, I can't format this. Okay, basic formatting is done. Yes, so these are mutations, and how we deal with the mutation? Same as query. The query is only for read-only data. Mutations are for updating the data. Okay, so same as query, we will define our mutation, and inside resolver we can create one. Mutation.js is already there, so here we can just say const mutation, and inside this object we can define our functions, create user, and every function, either a query and mutation, takes same set of argument, parent arguments. Here this is context and info. Okay, and here from the argument we can get all the data we need. So if you just see const data, I can access it from argument, and here I can check, okay, if the data is there, if this particular email is already taken, all these things we can do. Let's say first we will check email, argument dot data dot email. I'm just doing a destructuring const, then we will say, okay, email taken or email available, something like this, right? So what we will do is we have to import. For now we are importing these things, but in future we will do it differently. Import users from our DB. Okay, this is a JS file. So here we can say users dot sum. If any of the user having the same email ID which this new user is having, then we will not allow creating this user. So user dot email is same as the email you are passing. If any of the record match with this, then we will say, okay, you can't create this. If email taken, then here you can do a lot of things, throw new error. We can write custom exceptions also. Email already taken, blah blah blah, something like that. Okay, so we are going to write these kind of mutation functions, same as query. Let's say this is for create user, there is another function update user, keep adding them. There is a delete user. For now we are just playing with the mock JSON object. This is the data we have and we are playing with this, but we will define a strategy to access the data even we are not using any kind of database. So this is a mutation, we will import this mutation inside our index.js, same as query. We can say this is our mutation, and we are getting it from a mutation file, and specify the mutation here. That's it. Okay, so this is the basic setup, restructuring of the same code into a different definition. Now we will see all this working in the next video. Hi everyone and welcome back. And this weekend we are going to talk about again on the GraphQL. If you are following this playlist, then we have already talked about Yoga GraphQL and we have covered the basic fundamentals on the GraphQL. In the last video, we did the folder restructuring, we wrote the resolvers and the query and mutation. All these things we were able to bring, and we were able to write the Monk database, and we were writing the GraphQL schema. It's just a quick recap that what we are covering and what we are going to cover in this playlist. So till now we just talked about this particular yoga lady, which is Yoga GraphQL, and we have covered the basic fundamentals. Even without database, we have done all different things like query, mutation. We will talk about subscription. So we are not using database till now. We are just playing with the mock JSON object. But yes, we will introduce MongoDB, SQLite, MongoDB, Postgres, MySQL, and we are going to use these different ORMs. So you might see different icons, right? This is the type ORM and popular ORM in Node.js. SQLite is another one of the popular ORM. Prisma becoming popular, and we are going to work with the GraphQL using Yoga GraphQL and the Apollo GraphQL. These are the two primary library we are going to use in the whole playlist. Okay, so I think now the quick recap is done. We can go back and start writing our code. Okay, so in the last video what we did is we were able to restructure everything, like creating a resolver as a new folder, putting all the resolver definitions like mutations, queries inside that, and then creating a separate folder for our mock data, which is a db.js, and then GraphQL schema as separate file. So this is like separation of concern. Each and every file has its own meaning now. This is for database, this is for our yoga GraphQL JS. Here we are bootstrapping everything. This is our schema file. Okay, so till now we don't have much on the mutation side. We have written the query, we have seen this up and running in the last video, that how we are able to test all these query and mutation using the browser, I mean by hitting the HTTP post, and we were using this GraphQL add-on. Okay, now in this video we will go ahead and we'll start talking about more on the mutation side, because queries we have done a lot. We have written all these post query, user query. Now we will write mutations which will update the data. Like what kind of mutation we can write: create user, update user, delete user, kind of CRUD operation, which we actually do with the database. Currently we don't have a database. This is the only database we have, a mock JSON. Similarly, create post, update post, delete post, create comment, update comment, delete comment, and all these data is interrelated. It's not like we are doing post independently, user independently. We have linked these entities. So if you try to get the post, you can also get the user who published it. If you try to get the comment, then you can also get the author who published this particular comment. Okay, so this is pretty much. Now what we will do is we'll go to our mutations, and here we will define our mutations. Mutations are like here we can talk about create user, update user, delete user, all these kind of mutations, and it's all about based on the payload. So first of all we will define our schema, like what should be the input for the create user, update user, and delete user, right? So here we are talking about all different mutations. First we are covering only simple user operation. Create user, you are passing create user input. Okay, create user input is another type which is passing all these three parameters. Then we have a delete user, you have to pass the ID to delete a user. Update a user, where you have to pass the ID and the user input. Similarly we have three more. Let's say this is for user, then we can also have something for post. So it will be create post, delete post, and update post. Okay, this is update post, this is delete post. Okay, here what we are going to do is update create post. Here the input will be the created post input, and it is going to return as a post. So post is a type we already have. Delete post, it is also going to return as the post which we have deleted, and the update post, it will also return the post. Okay, similarly we can have something for the comment. I mean these are like basic operations. If you can understand one like user, then you can do post, you can do comment, and you can do anything else. So it's like create comment, it will take the input created comment input, and it will return comment. Similarly delete comment, it is taking ID and it will return comment. Then we have update comment, it is taking create updated comment input. So these are custom types we have defined. You can see custom types we are using here. Update user input, this should be update post input. So create post input, update post input, create user input. Let's call it as a create user input, update user input. This is create post input, updated post input, create comment input, update comment input. Now we need to define these types also. It's not like we can go ahead just without defining them. So we have create user input and update user input. Now we have to define four more. One can be a create post input, which will take title, body and published. Title is string, body is string, and published is boolean. Okay, and all are required. I mean, title, body and published. This is the create. Then we have the update. So in this create, everything is required. We also have author, which is of type ID. So all are required in the create. Then we have update post input. You might want to update the basic information but not the author, right? So update post input, like I'm the author and I'm updating it, so obviously I will be just updating either title or either body or either published, not the author. Similarly, we have two other types, which is create comment input and update comment input. In the comment, what you will add, let's change this to create comment input and update comment input. Now in the create comment input, you will have text. These all properties will be required because you are writing a comment, and there will be author as an ID and post, on which post you are adding this post ID and author ID. We have two things, post ID and author ID. This is the comment, and when you want to update it, we don't want to change the author and the post for the comment. Only the text is something which you can change. So these are required, this is optional. So we have defined all the different types. Now what we can do is we can go ahead and write these resolvers. Okay, before that, user is returning posts and comments. Post is returning comment, and author, post and author, that is fine. Okay, for post, comments can be many, right? Because you can write multiple comments on a single post, and comment will have author and post. So we are just adding some additional relationships which are required. So we have post, we have author, and for the post we have author and comment, and for user we have posts and comments. So this is our user, posts and comments, and these we have to write a logic how to resolve them. Like we have put that here, user had posts and comments, and this is how your query needs to resolve when you want to return the user object. Similarly, we have post. In the post we have author and comment. In the post we have author and comment. Now in comment we have author and post. In the comment we have author and post. Okay, there is author but we don't have a post, so we have to add it. So post means this is another one. So what we are doing is we want to get the post of the comment. I mean, you can also return the post information on which you have written a comment. So we can do is db.posts.find, and the condition will be post.id. Okay, so it's like parent.post, and we can say post.id, i.id. So if we just go ahead and look at the data for the comments, we have author. So we also need to have the other information with the comments, which is we need to also have the author ID, so that we can, author ID is there, post ID, I mean on which particular post you are adding a comment. So our post ID can be something matching, like on the post we have the ID 10 and 11. Let's put as 11, and here let's put the post 10. Okay, now we have post and author, and we'll go to the comments. How to resolve post? We just need to find parent.post. Here we have given the post ID, which is nothing but this ID belongs to the post. Okay, that we are getting from the parent. So parent.post equal to I.id. This is fine, right? So this is how we can resolve both the information author and the post for a comment. Post.id equal to parent.id. Okay, so this is one thing. Now what we can do is, let's go to our GraphQL schema. We have defined all the mutation, but that's not enough. We have to go to our resolver, and inside resolver we have to define all these mutations. So here is our mutations. In the mutation currently, I mean, we haven't covered all these things inside mutation. Until we haven't covered them, it will throw an error. So first of all, let's list them down, what all we wanted to cover. These all things we are covering. So let's write our mutations, like create user, update user, delete user, and all these things. So create user means we will get the data, and we have already defined the payload for create user is this data, where we are going to have a name, email, age, and we can access this object through argument object. So let's go to our mutation, and how we are accessing this from argument.data, because data is the parameter name. From there we get the email, and first we are checking if this user is already registered with us with the same email. Then we are going to throw an error. Otherwise we are going to create a new user, and we need to provide a unique ID to the user, so we can import UUID from UUID library. So this we can do, and here we are creating a user. It's not like we are going to store this in the database. We will just push it to our mock JSON object, and here is our argument.data. This is the user information, and then we do have access to users. Okay, this is the context, right? So from context we are going to get the database, so we can restructure it directly db, and we can say db.users.push. user is already an array, our new user object, and once it is done, return user. Simple. This is how we are doing create user. Now update user, first we will try to see what is the user index, right? What is the user ID? So here in the update, what is the payload? We will talk about user, and then post and comment is kind of same thing. Here we have the name, email, and age, that is about update. Okay, and we also going to have the ID, because update will happen through the ID. Yes, this is there. So we have the ID and we have the data. ID means the user ID. So here we have the update user. What we are doing is we are getting ID and user from the argument, right? And then we will just try to find if the user already exists. I mean, user exists with that ID. Users dot find, and we will say if user.id is same as the ID you are passing, that means the user exists and we can do the update. But if this user is not there, that means we can throw an error, throw new error, and that error will be user not found. Okay, now if user I mean, we are able to find the user, now you are trying to update the user with a new email or something like that, so that we can do. but again we can check, okay, the user already exists with the same email or not, right? That is again a concern, that there should be no two users having the same email. So email taken, we are capturing user.email, right? If the email already taken, then we can't create with the same user. Otherwise what we will do is, if all these tests are, I mean all these cases are passing, user.name is data.name, we don't need a uniqueness on the name, user.email equal to data.email, and we have updated the user and we will just return it. Okay, so because it's the same reference, we just updated the properties on to the user, and this user will be updated in the database. Return user. Now let's say there is a create post. Create post is also kind of same thing. In the create post, what all the argument we are passing? If you see the create post, we have author, title, body and published. So we can try to do this create post and update post. First let's do it with the create post. Okay, for the create post we are going to first we are going to validate author really exists or not. It's like all data validations we are performing. Okay, so argument.data, here we are getting argument data from, first of all, what is the payload? Payload is create post input. This is the payload. So we will have to check, okay, does this author really exist with this ID in our system? So we'll do that validation. Inside this data we have data.author, and we will just check with the ID and users.sum. If any one of the user has the same author ID which we are trying to apply for the post, that means we have the author really exists, right? Otherwise author doesn't exist for this new blog post. Author does not exist. I mean, these are just the validations we are trying to put. Now it's a post object. We are just passing the ID and rest all the payload, where you are passing the ID, I mean body, title and the author information, and db dot posts dot push new post, and this return this new post created. This is our create post. Now update post. In the update post, what we are doing, first of all we are trying to get the data. Here we are getting two things, ID and data. First we will do check. First we will check, do we have this post with this ID exist? So we are just checking post.id equal to the ID which you are passing. It's like update post by ID, delete post by ID, and create post with author ID. Same, right? So we are just saying, okay, the post exists. If post does not exist, we will say post does not exist. Otherwise we will just update some properties, whatever is coming in the payload. You might add some null checks there. It's create post, this should be update post. We didn't change the name. Update post and post exist, and then later you can do is simply we can update the properties. So this was create post, update user, something like this. So we got the post because this particular post is there, so we'll just update the same property. So here we can update the post dot title, body and all these properties. Post dot body. So in data we have all these properties, data dot title, data dot published, and return the post. That's it. So it's like plain and simple we are able to do here. So similarly we can create a create comment, update comment and all. Let's finish this and we will run this in the next video. Hi everyone and welcome back. So in the last video we have done the restructuring. Now we have the resolver folders, db mock database. We have index.js, which is combining or collecting everything together, the resolvers and type definitions. Type definition is a separate independent file where you can define all different types you want in a one single file. Okay, and we have all the resolvers. So everything looks structured now and we are able to run this. And we can also see this working. We can now also can see the mutations here, right? Mutations are something which is changing the state, right? Create user, update user, delete user, create post, update post, delete post, create comment, update comment, delete comment. These all can be a mutation. I mean, these are just a basic examples, and these are some custom types we have. We are exposing here, right? Create user, delete user, and you can call these mutations same as query. This is add query, and this is here you need to pass the whole JSON payload, which talks about, okay, because it is taking created date user input, right, which should have name, email is in this payload. We haven't created the mutation properly, so I'm not testing that here, but we can test all the queries. Okay, so this is just about restructuring and everything is working as expected we wanted, right? So now what we are going to do, the another change is, you might have seen that in each and every resolvers we are importing this db definition, right? So is there any way we can pass these db definitions in the resolver function? So we need to understand that definition of all these parameters. Parent, argument, so whenever you are passing any argument in the payload in the body, I mean, we are just only hitting the http post with the query and mutation, so everything will goes in the argument. And the context, anything you are passing in the context. So GraphQL server is taking 3 or 4 argument, right? First is type definition, another is a resolver, third is a context, and this context can be accessed in your query and in your mutations. So what we will do is, we are going to pass this db. This db you can consider it as a database source. Okay, we are going to export only db from here. So we can say const database, and this database contains all these things: users, then we have posts, and we have comments. Then we can do export default database, and we can import this database definition inside our index.js. This is in the same folder structure. Import database from db, and if I wanted to access anything, then I can do a database. Let's just call it as a db for the shorter syntax, and now I can pass this in the context. Okay, this db context can be accessible to any query and any mutation or any type definition. So how we will access it? Let's go to any of your resolver like comments. Okay, I can access this context is the same object, and I will just use it. Now I can just say db dot. So db contains all the users, comments, and posts. So I need to make this particular change everywhere, and we don't need to use this import definition now. This is comment. Same we can do for the mutation. Wherever we are using, we can change that definition. Okay, and now we are going to access this comment, posts, and users from db dot. Okay, sorry for this. Now I can do is db dot. Maybe this may not be the better naming, we can put something else. db dot users. Same we have to do for the queries and for all the types, right? Posts, queries, and users. Okay, in query we have this context as third argument. We can use db there, and then from db we can access db dot posts, db dot comment, everything. Okay, here we have post, so I can say db dot. Here I can say db dot, right? So this is the minor change we are doing, and why we are doing is because here we are passing this data source in the context, and every query mutation can access this from the context object. Here it will be a data source. It can be a simple mock JSON, it can be your MySQL database connection, Postgres database connections, or here you can pass a lot of other things also. Like I wanted to pass the current logged in user object, so I can pass it. The session information, currently logged in user session information you are maintaining, you can pass it. So this user session and db all can be accessed in the query and mutation to know what is the current user, what is the role of current user, if current user is logged in or not. All those things you can access inside query and mutation. So that's it about this particular video, which is talking about how to pass the context and how to access the context in your query and mutations. Hi everyone, so in this video let's see this up and running. So here we have all our mutations, like we have defined create user, update user, at least create post, update post, create comment and update comment. We can focus on these, right? And what we are doing is we are getting this db from the context. So this is where we are passing the db as a context. Here this place is something where you can pass the database connections, some mock data, and some global data which you want to publish to all the query and mutations. So this db is available in the context. So if you go to any mutation in this context argument, you can get the data source. So here we are destructuring with the db, db.users, db.posts, db.comments. This is how we can access the data. So these are the some of we have written, like update user, create user, right? Now if we just try to run this and try to test it, it's plain and simple. We'll open our browser. This is Altair as a client, right? And this is how we are specifying our payload. So if you go to all our query and mutation, first of all refresh this so your document gets updated. It can fetch the latest definition. These are the queries, and this particular, these are the mutations, like create user, update user, create post, update post, delete post, create comment, update comment, delete comment. Okay, if we just simply start with this delete user, okay, it is also giving us the id. And if we simply start with this mutation, which is create user, right, in create user mutation we have to pass this data, right? This is what it is looking for. This contains the name, email and age, because the create user input has these properties: name, email and age. So we have to pass them. We don't want it to get the posts and comment information. So let's run this, and this email is already taken, so it's like a validation error, right? And we are not doing any email validation errors, email validation. So if I run this now, this will start coming. Okay, now I can go and try to fetch the list using query, which is like give me all the users. And here I don't want it to pass any particular. We can't return null for no nullable field query dot users. Okay, so first of all let's see this users. Okay, we need to pass some argument here in the query. If we go and check our query for the users, it is accepting this query as an argument. And then what we are doing here is, okay, some code is not updated. This should be a database, because now we started passing the db, and it should be db.users, right? And this is how it is going to be. This is a little bit old code. Here we are going to get db, and we are going to filter out based on db.posts. Okay, similarly for the comments and all. Now what we are doing here is just save it so this server can restart. Okay, so here either we can pass query which says, okay, I'm looking for this particular user having this title, and just run it. There is no any user, right? So these all are query and mutations. Mutations, like you can also do the create post and all. In the create post, if you see what argument we need to pass, create post payload, here you need to pass a lot of arguments, right? Title, body, published, author. And if any of the argument you are passing wrong, let's say first is title. Why it's not coming? Okay, it should be an object first, and then you will say title, something in the title, then body, something in the body, and we have published, which is I think a boolean flag, true, and then we have author, which is author ID. Okay, if I try to publish this now, then it got published. We have author ID is a valid author ID. We can still do the testing. It will create a new one, but if you wanted to update, then you can use this ID, right? And you can update the title and body. Let's say this update, right? In update, we are going to pass the ID, which is the created post ID, and the data can be these properties without author ID, published, and this we can trigger. We don't want to populate these properties for now, and this is updated, right? We can just pass whatever we want, the garbage values or something, and it will update that. Okay, so this is all about the query and mutation. The mutations we have written, we are able to test all the mutations here, right? Now next thing we are going to talk about subscription. Okay, few things we have to update in our code while doing a query is now we are using the DB, so you can access this DB from the context like db.post, db.user, db.comments. Okay, next thing is subscriptions, like you wanted to subscribe a change happening on the comments. Whenever the new comment is added in the blog post, I should be able to take a particular action, right? So let's talk about the subscription in the next video. Hi everyone and welcome back. So now we are going to talk about subscription. So in the previous couple of videos, we are done with the query, we are done with the mutations. Now we understand how to run them, how to test them from the GraphQL client. Now next important part which we are going to talk about is the mutation. Mutation and subscription. I mean, mutation is all about changing the data, and subscription is all about listening to a particular type of mutation and acting upon it. Okay, so it's like an interesting, you might have already heard about event emitter in Node.js, where you emit an event from one corner of your Node.js application, and there is a listener who is listening to the same event emitter and can act on to that particular action. So same thing we are going to talk about. I mean, in the same context, this is called a subscription in the language of a GraphQL. So we are going to use the pub/sub, like how to set up this. The basic setup is we are going to get this pub/sub from the GraphQL instance only. So you can compare, you can think about this as a Redis pub/sub. So GraphQL server, this is how we can set up, and we have to pass this pub/sub instance. We have to create const pub/sub equal to new pub/sub, and just pass this pub/sub instance to your context. Now you can access this pub/sub in the same way you are accessing this DB from the context, right? db.post, db.user. Similarly, pub/sub you can directly access. It is a small pub/sub. Okay, keep it small only, and we can access that in the query and mutation. Mostly we need it in mutation, because from mutation, after a particular change happened, like comment added, comment deleted, comment created, we want to publish a particular event, and there is a listener somewhere which had subscribed to your mutation change, and it will be able to listen to those changes. I mean, it will be able to act on to that. Okay, so GraphQL Yoga out of the box is supporting that. You just need to create the instance of pubsub and provide it in the context so that your mutations and query can access it. So mostly we are going to do it with the mutations. Like let's say I am adding a comment. Let's say here in the bottom we are adding a comment or updating a comment, and there I wanted to publish a particular subscription, publish a particular event, right? So how we do it? Whenever we are doing a delete, update and create mutations, there we always have a chance, okay, the data state has changed and now we wanted to notify something. So these subscription are special kind of types which are nothing but a watching about the change of the state of your data, right? The syntax is very much similar to the queries and mutation. Just we are just going to add a subscription.js, and in the index.js we are going to pass subscription, same as the mutations and all. We will pass the subscription here, okay, and same way like we have the query, we have the mutation. Similarly, there is another file which we are going to pass as a subscription, and we can import subscription from subscription. This is the basic setup. So subscription we are going to write, and subscription will listen to a particular changes happening onto the data. Okay, so what we will do is GraphQL document already provide how this subscription works. Is we'll go to our mutation, let's say, and we want to listen to a particular change. So what we can do is we can access this pubsub which we are passing to the mutations and queries. Let's say I want to do it with a simple update comment. I want to notify. So this is the update comment. From the context I can access pubsub. Okay, and now I have this. So I can do is pubsub.publish, simple pubsub.publish, and here I will just put let's say dummy event name, comment updated. You can also pass the comment ID, and here is the payload. In the payload you will be saying, okay, this is about comment, and here I'm doing, this is the mutation which I'm talking about. This is updated and data about the comment which I am updating. That's it. So you are passing this as a context, and this is the publish pubsub.publish, right? So we have done the one part of it, like publishing it by accessing the pubsub from the context. Now we need to write a subscriber who is going to listen to these kind of events, right? So we can create subscription.js. It's again going to be the same kind of logic like we write in the query and the resolver. What we will do is const subscription, and this is an object, and this is going to handle the comment level subscription, and it is going to have subscribe method. Inside subscribe method, this is inside a comment we will have the same methods like we have inside the resolvers and query. This is the subscription for the comment. We will also have another kind of events coming from the post. Okay, we are going to handle it in the subscribe, and we have the same set of argument here in the subscription, same we have in the query and mutation. Here we can get some data. This is the context, so we are going to access db and pubsub, and the last argument is the info. Okay, just a simple boilerplate. Now we can also publish the events, something from the mutation from the comments, let's say comments and the posts. Let's say what I want to do is I have added the post, I have updated a comment, created a comment, or I have published a post, right? So create post. There are many places from there we can actually publish this, because now pubsub is available everywhere. And we can do is pubsub.publish, and we can say the blog post is created, and somebody who is watching for all these kind of states updates can receive those changes. So pubsub.publish, mutation is created, this is the post. Similarly, from many different places you can publish this. So I have delete post, updated post. Here also I have a pubsub. So if you are deleting a post or updating a post, I can do the same thing. Here it is updated. We already have the post data. Here it is the create comment, delete comment, update comment. Similarly, we can actually publish these kind of events. And here is our subscription who is listening to the change happening in the comment and the post. So the subscribe methods is something which is handling it. And inside subscribe, what we are doing here is, if we go to subscribe method, here we have the parent and post ID which we are sending, and in the subscribe method we can actually get which particular post ID we are talking about, right? So here we already have access to the DB. Simply we can just do db.posts.find. Okay, I have all the posts. Which particular post ID you are talking about? Post.id equal to the post ID which I got from this mutation. Okay, I got the post, and I will just simply return this using pubsub dot async iterator. And you can say okay, updated, deleted, or commented, right? So this is the information you are sending. Updated post ID. So this is how your subscription will handle the events coming from the mutation. Same kind of logic you will be doing for the comments. Okay, so this is all about the subscription. We will see this real in the example how it really works when the blog post is updated, deleted, and we are writing the subscription also, which we will just import here the subscription, and then let's see how this works with the GraphQL console in the next video. So let's talk about the next part of subscription. Here we have written the basic subscription. Okay, here we have the mutation. Let's say when you are deleting the post, here you are sending the mutation, which is a mutation type created, updated, deleted, and this is your payload. Okay, and you are doing a different kind of subscription on the post and subscription on the comment. Okay, so subscription are also kind of similar. We have to define their type definition same as the query and mutation. So we will go to schema.graphql, and here I have defined the subscriptions, comment and post. Post is just going to return as the payload whatever the updates are happening, and the comment is just going to take the post ID. Okay, you have commented on this particular post, deleted a comment on this post, updated a comment on this post. So this is the two different types we have. Like mutation is a created, updated, deleted. This is having the post payload, this is having the comment payload, right? So this is the new type definitions we have added for uh, updating the post, deleting the post. We wanted to publish publish an event, and there is a subscriber which is listening to this. Here we have subscribers on to the comment and on to the post. It is doing nothing but it is just publishing the whole payload, and it is just acting on it, like it is checking the post ID really exists before acting on it. Because let's say you have added a updated or deleted a comment and you are passing the post ID, then we have to make sure the post ID exists or not, then just do a sync iterator, so that the subscriber should be able to listen to those set of events. Okay, so how do we test it? First of all, we will just update the schema GraphQL. We have two different kind of subscriptions. So whenever we go to the documentation, here we should be able to see this is the query. Okay, this is not that user friendly, I will say. So here we have two subscriptions, right? Comment and the post. And if I open the documents, then you can see the comments and post. This should be enough. Now what these are about. So if you look at the mutation, what we are doing is whenever you are adding a comment, when you are deleting, or whenever you are updating a post or deleting a post or creating a post, we are actually publishing one event. If you are like updating a post, we are doing this thing like pubsub.publish of type post, and this is the whole payload we are sending, right? Same with the comment the payload is like this, pubsub.publish the comment and the post payload. Right now what we are doing here is, once we are going to simulate this in the testing environment, let's say here we have this, okay, here we have mutation. So there are two things, we have create and we have update mutation. So I will try first with the create post, where you don't need ID, you just need to pass the data. Okay, inside data there are a lot of things, title, body, right, this is of type string, and then there is a published, another flag which is of type true, and then there is author, I think, which is of type ID. I'm putting 1. This is like I'm creating a post, so I will hide this for now. Okay, I have created a post. So create a post with some real data, test and test. Okay, you can see this post is created, right? Now I'm updating it. And how you need to test the subscription, whenever there is a create is happening, what you need to do, you go here and open another tab and put your subscription here and start listening to those subscription. Click onto this arrow, it means it is listening all your subscription. Okay, there is a listening event is happening right now. What I will do is I will update this particular post. This is the ID which we just have created, so I will just pass this ID and then new data, and I will submit this. We got the new data and we are listening to all those set of events, so we got the new updates. You can see the same ID ending with 636, and here also you can see the ID ending with 636, the last updates. This is the create and this is the update. So here we are listening to all those subscription, and this is just a little tricky how to test your subscription once you develop them. So we are sending two things in the post payload, the mutation type, created, updated, deleted, and in the data we are just sending the payload, which is ID. Okay, similarly when you update comment, delete comment for a particular post, there is another subscription, you need to start listening to that subscription in another tab and go to your first tab, do the mutation like adding a comment, and you will start listening all those events here. Okay, so this is all about how to write, how to set up, and how to test the subscriptions. I mean, this example is available. I have also published one sample example which is very small and very simple, like update user, create user, without these comments and posts and all. Okay, that's it guys about subscription. So we have covered the basic fundamentals like query, mutation, subscription with the Yoga GraphQL, and we have covered it with the mock database. Now we can go one step ahead, like we will restructure our modules. We will give a modular structure. We will split this schema also for all different entities, like we have a post, we have comment, we have user. Every folder, it can be more modular, every folder can represent a particular entity like user. It has its user MongoDB model and all the queries and mutation you will put there. Similarly the comment, similarly the post. We will try to restructure it so it is more productionizable application. Let's see that in the next video. So this is all about the basic fundamentals we have covered. Hi everyone and welcome back. So before moving further, I want to cover one more example on the subscription, and this is fairly simple than the previous one. We don't have a big schema, and we have a simple mutations and a simple subscription. Okay, so what this example is, it's talking about user entity, update, delete, and create. Okay, and from these mutations we will be publishing and we will be writing the subscriptions. Okay, so this is the user type. User has nothing but age and name. Create user is having this add user input with the name and age, and the type user has these two attributes. So you can see there is a query which is giving us the list of all the users, the mutations to update, create, delete, and then there is a subscription we have written which is listening for all those kind of events on the user entity. So user subscription is a type, mutation is of type string, and data is of type user. Okay, so this mutation should be of type mutation type. This is wrong. Yeah, mutation is of mutation type, which can be created, updated, deleted. Okay, and these are the resolvers. Resolver means the query definition, it returns all the list of users we have, and then we have update user, delete user, and create user. Now from these mutations, what we are doing is we are able to access the pub/sub from the context.pub/sub. Here you can see here we are accessing pub/sub. I mean, we don't have multiple files, so we created a pub/sub on the top, and we are using this pub/sub only. Otherwise, what you can do is you can pass the pub/sub in the context. Here in the resolver definition, you can pass the context, and then you can access this pub/sub in the context, but that is fine. So here we are doing pub/sub.publish user event, and this is the payload. Mutation type is added, created, deleted. Okay, and this is our simple subscription definition in the schema. This is looking for the user subscription, and it has subscribe methods, right? Simple logic, and like we have create user, update user, they are publishing this kind of event. Pub/sub.publish, user created, user deleted, and user added, right? So once you start this application, once you do all these mutations like add user, delete user, update user, and if you are listening for this subscription which is like user, and it is just returning a simple payload. If you see this on the top, the subscription is just returning the user subscription payload. So if you if you start listening for all the events coming for the user subscription, you will receive this payload with the mutation and user data. Okay, just another example just to explain and make it more clear. These are the mutations, this is the query, because GraphQL is all about query, mutation, and subscription. Query and mutations are simple. Queries for reading the data, where you can list all the users, return a single user, return a multiple users. Mutation is all about updating the state of the user, and subscription is all about watching onto the state of a particular entity like user, posts, comments, particular post. I mean, watching for a particular post ID, watching for a particular post having updates on the comments, right? All these different kind of subscription can happen. Okay, I hope like this example is, I will put the reference, the GitHub link. This I got from the GitHub only. So this is just for making it more clear. Now from the next video, we are going to talk more about Yoga GraphQL and make it more structured. And we are going to talk about some advanced concepts of GraphQL before we go to the database side, like GraphQL with Yoga GraphQL with a MongoDB, Yoga GraphQL with a SQLize, TypeORM, Prisma, and all. Okay, thanks everyone. Thanks for watching. Hi everyone, and welcome back. Welcome to my YouTube channel. And since last 2-3 weeks, I was not posting any latest video, but now I come up with the latest playlist on the GraphQL, playlist on all different kind of ORMs in the Node.js, and we'll also talk about Kubernetes, the Neo4j, and everything from the latest technical stack. Okay.